talking about spooky reactions. Ooh. Okay, so I have a few questions for y'all to think about. What happens when you have lemon powder and water and you mix them together?
Oh, lemon juice.
Raise your hand and tell me.
I think it'll make kind of like a type of lemonade lemon juice.
Yeah, so like it could be called lemon powder or lemonade powder, either one. Anyone else have any other thoughts? Cole?
No,
The same as hers? Did you have a different one? Anyone have anything different? No? Okay, so what does it make? Tell me if y'all all thought. What do you think? Lemonade, yeah. Because you have the powder and the water, and when you mix it together, you get lemonade. So what happens when you have peanut butter and jelly and you mix them together? Riley?
A peanut butter and jelly sandwich.
That's right. Exactly.
I knew that.
What do you have to say?
You forgot the bread.
Oh yeah, you do have to have the bread to make it a sandwich. That's very true.
Do you have a cow?
That's true. Okay, so I have one that might require a little bit more thought. What happens when you mix baking soda and vinegar? Raise your hand if you know. Yes.
An explosion.
An explosion? What do you think will happen? It will fizz? What do you think, Easton? You think it'll fizz? What do you think? It'll melt? That's a good observation. That's a good.
Have you seen the elephant toothpaste?
I have seen elephant
I think
toothpaste.
it's gonna act like that, just smaller.
That's a really good thought. Comparing it to something else? Yes?
I think it might fizz or kind of bubble.
Yeah? Any other thoughts? Yes?
Like bubbles and
Make bubbles? I think those are all really, really good ideas. So I want y'all to remember those because we're about to do it. We're going to see what happens. I know, yeah. So Gracie and I, we carved this pumpkin and we're going to put vinegar and baking soda and some other stuff, some glitter and soap.
I hope it looks cool.
And we're going to see what happens. So y'all remember what you said think was going to happen, okay?
If this was gonna explode,
Okay,
So
so
we'll have to wait and see. It might do that.
okay, so before we start, if you need to come to the front to see, you can. So like y'all can come up here. It's kind of down low, so you'll have to be up close to see what happens. Y'all can come around the back too. Just make sure we can see it. Oh, let her go. She won't be able to see.
Can everyone see?
Oh, are you good?
If you know that you're a little taller, maybe let someone who might be a little shorter get in front. That way they can see.
You good?
There you go. Riley, can you see?
You're good.
There you go. That's smart to get on your knees. Can you still see? If you get on your knees but you can't see, you can stand back up.
Okay, so for this, I'm going to need 4 volunteers. Okay? Let's see. It needs to be somebody that's kind of close. You can be one. You can be one. Let's just do these 4 right here because they're really close to it. Okay, the first person. You want to do the first person? I need you to pour some baking soda into this cup. Okay? So here's you some baking soda. Got it?
Can you see bigger? It's right here.
Now let's pour it into the cup. I'll tell you when to stop. Little bit
here,
more.
come stand right
There you go. Stop. Okay,
There you go.
so far we just have baking soda in our cup. The second thing we need to do is add some soap. Who was our other volunteer? You're our volunteer? Let's do you. Can you add some soap? Put like 2 good squirts. 1. 2. Perfect. And then who was the other ones?
It was me, her, me, him, and him.
Okay, so Easton, do you want to add some glitter?
Green, gold, or silver.
Yes, there's some options.
Or
in there.
all of the above.
Or you can do both.
All of the above? Okay, he's going to do a little bit of all.
Oh, I like it.
Very glittery.
There's green, gold, and silver.
I think it should be open. You just have to twist it. The top. Oh, see if you twist this part to the. Oh, it's not open.
You wanna know someone
Be careful.
salt and vinegar and it got rid of the
Don't add a ton. Just be really easy with it.
and it
There you go.
glued and like poured on her face. You know those pennies?
The other ones I think are open, so you can twist the tops.
It got
Okay.
Just a little
Can I
bit.
put this back in the back?
put a lot.
There you go. Perfect.
That one's kind of spilling, so be
perfect? Okay. I'll take it.
That's okay. You can leave it right there.
Okay, and then the last person. I need you to add some vinegar. Okay? Was it?
It
Who was
was you
the
that
last
was
one? It was you? Okay, don't
Be
start
careful.
just yet. So, can everybody see for the most part?
Yeah, I can see.
Can you see? I'll turn it kind of this way.
I'm going on my team.
Okay, so add some vinegar to the cup on the inside. Okay, keep on going. Keep on going. Keep on going. There you go. Now stop.
I know.
What's it doing?
It's kind of like
Can y'all see it?
I
see it? What's happening to it? It's having a reaction.
throwing up.
That's a good observation.
Throwing up.
Okay. Uh-huh. After you've seen it, start going back to your desk so everyone else can have a good view of it. Make sure you look at it really, really closely.
Now, if you're in the back, make sure you see from the front.
I like to touch it.
Yeah, it's totally amazing my day.
Start making your way back to your desk.
It's like it's starting to
Okay, so we have a bell ringer. So whatever you observed, something that you thought was cool that you saw, or something that happened that you weren't expecting to happen, I want you to take the orange sticky note off of your foldable and write something that you observed about the pumpkin or the reaction with the baking soda. On the orange sticky note, yes. Take it off your foldable because once you write down your observation, you're going to put it on this pumpkin.
What's the observation?
An observation is something that you saw happen up here, something you observed happening during our little experiment.
Is there a right or wrong?
It could be anything. Whatever you saw.
You have to write your name on
No, you don't even have to put your name on it.
And when you're done, you can come stick it on the pumpkin. It's like pin the observation on the pumpkin.
Oh, just like it.
True, it's like pin the tail on the donkey, but pin your observation on the pumpkin.
I got an idea for that.
Good job. Thank you. Good job. Good job. It's okay. You can if you want to, but you don't have to. Good job. I think there's only a few more sticky notes that are out. I only see 3 more. Oh, 4 more. 5 more. We'll wait for y'all to put them up. It doesn't have to be anything crazy. It could just be something simple that you observed. Good job. We're just waiting on 1 more. 2 more. Good job. We've got 1 more. Once you put your observation on the pumpkin, you can sit back down. And we're going to talk about what? Just wait a actually, yeah, I guess. Okay, I think that's all. Has everyone put their sticky note up here? Yes, no, maybe so? Yes? Okay. So, we're going to read, I'm going to read some of these and y'all tell me if you saw it happen.
Okay.
This one says, it fizzed a lot more than I thought, and it looked really cool coming out of the mouth and very white and glittery. That was a very good, detailed observation. Did y'all see all those things happen?
Yeah.
Yeah?
That was a good observation.
That was really good. Okay, let's see. It rose and filled up the pumpkin. Did that happen?
Yeah.
Yes. Someone wrote, it looks like elephant toothpaste on it, and it had a cool reaction. Does anyone know what elephant toothpaste is other than the person who wrote it? Y'all do? So do y'all think it looked like that?
I don't know what it is.
What
It's kind of
about, I'll read one more. Okay, this one's got a good word in it. So it says, it says I. It fizzed up and out. From inside it fizzed and looked foggy, and it fizzed inside the fizz.
What?
So I like the word that it said it looked foggy, because it does kind of look foggy. Like sometimes in the morning when you can't really see, it's kind of like white and kind of foamy outside. It looks a little, so kind of foggy. Did y'all think that happened?
Kind of, but when like the other one, when you say like the other one, kind of makes sense.
Yeah. Well, it made sense to who wrote it. So.
Yeah.
Because everyone understands things differently. So I think we had some great observations. A lot of them say fizzed, and so it did fizz a lot. So I like it.
Okay, now that we've made our observations, I have 2 questions. The first one is, does anybody know what a physical reaction is? And if you think you have any idea what a physical reaction may be, you can do a thumbs up. But if you're not sure, you can do a sideways thumb, or if you have no clue, that's okay too, and you can do a thumbs down. So what you think? Does anybody know what a chemical reaction is? I see some thumbs about every direction, and that's a good thing because we're going to learn a lot today about chemical reactions. And if you have an idea of what a chemical reaction may be, you can turn to your partner and talk to them about what you think.
Talk to someone next to you about what you think. Are y'all thinking about what you think a chemical change is? Yeah, the first one. Yeah, I liked it. That was good. Okay. That's a good thought.
That's fine too.
Elephant toothpaste, when you put it in, it's really like strip.
It does.
Yeah, I want to use it. It's cool.
Yeah.
But it's kind of dangerous.
Are those yours?
Yeah, it's kind of dangerous.
I don't know.
It's actually
That's just
strong.
strong. That's ours. Have y'all talked about what you think of chemical changes? You did?
Yeah, tell them. Yeah.
Okay, that's okay.
Toothpaste.
So if you talk about chemicals,
Yeah.
we can now talk about physical. So if you have any idea of what a physical reaction may be, you can do thumbs up, thumbs down, thumbs sideways. Yeah. I see more thumbs up for that one. So, as we move on into our lesson today, we're going to see exactly what a chemical and physical reaction may be. So we'll see if our guesses are right.
Do y'all think your guesses are going to be right or wrong, or in the middle?
Correct.
You think they're going to be correct?
I think it's gonna be correct.
Okay.
Y'all ready to find out?
Yeah.
Okay.
Okay, so a chemical change is a process that forms one or more new substances. So you have a foldable in front of you, and on it there'll be a little part that says chemical change, and I want y'all to write this definition under the word chemical change. When you're done writing definition, I want you to give me an excited face. That way I know when you're done. I like all the excited faces. excited face? Okay, I think I see almost everyone looks really excited. Just got a few more people left. Alright, waiting on one more excited face. Actually, I see two. Oh, there we go. Changed it to an excited face. There you go. Yep, I think we're waiting on one more excited face.
Oh, I think I see all excited faces.
I do too. Okay, so we're gonna move on now that we're all excited.
Now that we know what a definition of chemical reaction is, we're going to look at properties that will help us determine if a chemical reaction has occurred. And there's also a place on your foldable, it's like diagonal, like right across from it, and it says chemical properties. Found it? Everybody got it?
Mm-hmm.
Okay, so as I read through evidence of chemical reactions, you can copy those down. And as you copy them down, they will be really helpful later on for an activity that we're going to do at the end. So the first evidence of chemical change that you may see is a color change. You may also see a temperature change, gas production, light emission, precipitate formation, and even a change in odor. And when you're looking at evidence of chemical reactions, all of these may not occur at one time. So like, you may just see a color change, and that would just give you a hint that it may be a chemical reaction. Or you may just see a temperature change. But they don't all have to happen at once for it to be a chemical reaction.
Yeah, do you have to write all capitalized or you can just put them?
You can write however you want to.
Yes. That's great. Do you have a-
Do you have the joker or something?
No, do not bring them back. Do you want them back? No. If you decide to do them, I can bring it back. Okay, thank you. Okay, did everyone get that written down?
Almost.
Almost? Okay, I'll give y'all a few more minutes. Do y'all think if you give me 0 to 5, how many minutes do y'all need left? 1, 2, 3, 4, or 5?
0.
Okay, I'm gonna probably say 3, 2 to 3 minutes. We'll do 2 minutes and then we'll check back in. So keep going if you're not finished.
On our way.
When you're done, show me a confused face. Look confused.
I think I see all confused faces.
I almost.
Oh, there's one. We're waiting on one confused face.
There you go.
I'm confused.
Confusion. Easton, what's your confused face? Show me your confused face.
His face is red.
Look, show me your confused face. There you go. You don't know what's going on? A shoulder shrug. Okay, I'm going to give y'all 30 more seconds to finish. That's a confused face. My confused
Take the best one.
There you go. That's a good
Take
confused
the confused
face.
face. Mine is the best one.
Okay, I think we're ready to move on.
Move on.
Okay, so we have some examples of chemical reactions. So, some examples are iron rusting, burning wood, of cooking an egg, baking a cake, fireworks, vinegar and baking soda, which we saw, and then a banana rotting. So when you have an egg, and it says cooking an egg. So if you have a raw egg, when you shake it, can you kind of hear, is it like liquid or does it sound solid? Or what does it feel and sound like?
Liquid.
A liquid? That's true, because when you shake it like this, you can kind of feel the inside moving, right?
Yeah, but
Okay, so I have a question for
Feel
you.
the chicken.
What happens when you boil an egg?
it gets hard.
It gets hard.
Later on the inside and the yolk softens in one spot and it just sits still.
Yep.
And the rest
It
of
kind of turns into a solid. And so
I do think it's
what was our definition of a chemical change? Does anyone remember?
No. Vinegar and baking soda.
The definition of a chemical change?
A
A process that forms one or more new substances.
So an egg, it's no longer liquid, and so the new boiled egg was formed. Right? Does anyone else want to tell me why one of these, I've already talked about the eggs, so do a different one and tell me why.
Hey, you have someone from Troy coming down for observing.
Okay.
Thank you.
That's our teacher. So can someone tell me why
Girls.
some of these examples are examples of a chemical reaction? Yes.
I might know why iron rusts.
Okay.
Because people sometimes wash it and then directly put on the grill and then it heats up the water, which makes rust.
Yeah. And can you look at your properties and tell me which one of those would make iron rusting a chemical change?
Color change.
Color change. That's one of them. Is there another one?
Temperature change.
Temperature change. Is that what you're gonna say?
And
Brody, what were you gonna say?
Yeah, basically that was what I mean.
That's okay. Does anyone want to talk about a different one?
I know the burn.
What's your name again?
McKinley.
McKinley. That's right. Okay, you tell me.
The baking a cake
Mhm.
would change because whenever you're baking a cake, it starts off kind of liquidy, and
Yeah.
then whenever it's in the oven, it gets kind of harder, but then it gets soft,
Mhm.
and then it turns into a solid.
Right, because we start with like the sugar and the eggs and the cake mix, and that's all liquid, or like little. It's not a solid yet, and then you put it in the oven, and it becomes a solid, right? So it becomes cake. Because you don't want to eat the eggs and the other ingredients, you want to eat the cake, right? What it changes into. So like the new substance form would be the cake, right? So what is the new substance form with fireworks? Because it's not like fireworks are inside and they just come out, right? What do you think? What do you think?
You can have like a little stand. I just have like a stick to it up, and then you can have a little stand, and then you can have a little fire thing right there, and I light it.
Yep, and so what's the new thing that's formed?
And there's light.
Yeah?
Oh, I think I heard it. Somebody said.
What'd you say? Did you say it?
Was it you?
I said light.
Yeah,
That's
that's right.
That's perfect.
Because all the different things, they come together and they form like a fireworks.
Yeah, I know what's inside fireworks.
What?
Gunpowder. Yeah.
That's true, that's what makes them go.
That's what I
Okay, so we're gonna move on to our next part.
Okay, so now that we've learned about chemical reactions, we're now going to look at the definition of a physical reaction. And on your foldable, there's also a place to write the definition of a physical reaction. So as I read it, you can start copying it down. And if you just write the first sentence, that's perfect, okay? So a physical reaction is a process where a new substance is not formed. It may cause a change in appearance without changing the matter.
Yes,
Which one is it? The physical change or the physical properties?
Physical change. It's at the top where you write the definition. Okay, and then while you're writing, can you think of what the difference is between the physical and chemical reaction? Does anybody know the difference between the two? What's the difference?
Physical reaction happens to you. It happens to you or something that is living.
Did you see a difference in the definitions?
Yeah.
What's the difference in the definitions?
It says where it's not formed in chemical change
the big difference between the two, and it helps us determine which one is taking place.
I only got the first.
You got the first sentence? Good job.
When you're done writing definition, show me a silly face. That way I know you're all done.
Do you have to write the whole thing or?
No, you can just write the main difference, which is that a new substance is not formed.
Oh, I've written.
That's okay. You can write either one. Whatever you prefer. There you go. I see a silly face. What?
In Japanese, or in Japan, these are known as finger hearts.
Oh, that's
It looks like the bottom of a heart.
That's true. I see it. Okay. Does everyone have a silly face? If you're done, I should see a silly face so I know that you've written the definition down. I think we're just waiting on 2 more. Oh, 1 more. Show me your silly face. I'll show you my silly face.
What is it?
Are you gonna go first or you want me to go first? You know how to do it? You can go. Okay, I think we're just waiting on 1 more.
We all want to see your silly face.
I just did it. This is my excited face. Ready? Oh wait, my silly face? I guess this is my silly face. You go.
Dude, that's what everyone
I think we got all sillies now.
All sillies?
Yep.
Okay, so we'll move on to the next part. Okay, so the properties of physical reaction, you have a little part on your foldable. It should be the only part left. Huh? Physical properties. This is the physical property part, so it should be right here on your.
Did you write it in the wrong spot?
You can draw
You
an
can
arrow
just draw an
if you
arrow.
want. That way you know that you can switch them. Don't erase it. Just draw an arrow. There you go. Okay, and you're gonna write a color change, a size change, shape change, a change in state of matter for your physical properties.
What kind of face you want to do when you get done?
Show me your sad face. Ooh, I see some good sad faces.
Tell you I like your sad face.
I'm not going to make myself cry.
Yeah, don't make yourself cry. Just make a sad face. That'll be good enough. That's pretty good. I see a lot of sad faces. Okay, I think I see everyone has a sad face on. Okay, so we're going to go to the next part.
So notice that we know what the definition and properties to look for when we're looking at physical reactions. These are some examples which will kind of tie it all together. Melting of an ice cube is an example of a physical reaction. Because if you think about it, when you have an ice cube, it starts out what? Solid, right? If it's already frozen, if you just get it out of the refrigerator, it's going to be a solid. But then let's say you leave it out. What will happen to it?
It'll be hard.
So when you look back at your properties, you'll see a change in matter when from melting of the ice cube. And then some other examples would be boiling water, mixing sand with water, shredding paper, chopping wood, and also mixing green and red marbles. So for the chopping wood one, we also talked about wood as a chemical reaction. But as a chemical reaction, it was being burned. But then for chopping wood, it's a physical reaction. Does anybody know why chopping wood would be a physical reaction and not a chemical? That's kind of tough, isn't it?
Yeah.
Do you have an idea?
I'm trying to think.
You're good.
Maybe it's because instead of for physical, you're burning it, and for
chemical?
For chemical, you're burning it, and for physical, you're not burning it, and it's still all together.
Yeah, it's still going to be wood. When you chop it in two, you still have two pieces of wood that are going to look exactly alike.
It's kind of like this. If these were two pieces of wood and you cut them apart, you still have the two of the same pieces of wood. Like these are both erasers, and they're still erasers when you take them apart.
Yeah,
It's like nothing, no new substance was changed because it's still erasers.
yeah, but if you burn it, it turns into ash.
Right. So then that would be a what?
chemical.
Yeah.
Good job, y'all are listening really well.
What's your question, Houston?
How would be a physical reaction if you mix green and red marble?
A physical? Because when you mix them together, was anything new formed?
No.
Like there's still red marbles and green marbles, right? They didn't mix together and form like a red and green marble, did they?
No, ma'am.
So it's still the same. It's still the same thing.
Ready?
I think there's.
Yeah,
Yeah,
another
I
question.
have an idea
Okay.
about about melting an ice cube.
Mhm.
It's changing its state of matter by turning from solid to liquid.
Temperature change.
And if for shredding paper,
Yep.
I saw it's changing its shape, I think.
Yeah.
Because it's turning into little pieces or something.
Exactly.
Like a piece.
Exactly. Yes.
You done a good job using your proper.
Yes, I like how you use your foldable to make those decisions.
This is like not really a part of this, but have you so it's like melting an ice cube. It's a solid and a liquid,
Mhm.
and it's called uva.
Oh, I've never heard of that before. I'll have
It's
to
just
look it up.
cornstarch and water, and if you punch it, it's hard, but if you put your hand in slowly, it's like it feels like water.
Oh.
Lots of YouTubers have done challenges with
Mhm.
it where they can run atop of it, but whenever they sink in, they would like try to jump out and they can't.
Oh, that's cool.
You can even take a sledgehammer and sledge it, and it
Whoa.
won't break. It's
I'll have to look that up. I'll look that up later. Okay. I think does this make sense to everyone?
Yes, ma'am.
Yes? Okay. Perfect. Now, I want y'all to think back to our pumpkin experiment up here. And do you think that it was a chemical change or a physical change took place? Talk to your neighbor about what you think occurred. And I'm going to call on a few of y'all to share what you think.
Make sure you have like how you can back it up. How you
Yeah.
can back up your
If you say physical change, you have to tell me why you think it's a physical change. Or if you think it's a chemical change, you have to be able to tell me why. What do you think? You don't know? Look back at your properties. Did you see? What? It's okay. Just what do you think?
Can you back it up?
I don't know.
You can back it up.
What do y'all think? It's okay. Sometimes, what do you think? Look at the properties. What do you think? What did y'all see happen over there when y'all looked at it? I think it's chemical. Why? Which one did you see?
Yeah, all three chemical. You don't know?
Because it came up vinegar.
Are you not sure? We're about to find out.
Yeah, there's a change in odor.
If it's chemicals?
There's all kinds of different right answers. So,
I like exploding.
y'all keep thinking about it. See if there's any other. It's okay. Are y'all thinking? Oh, don't do this yet. Pretend that's happening. Y'all talk about what you think you saw? Okay, we're gonna talk. Okay, has everyone talked about it and kind of decided what you think?
I think we should do a poll.
Okay, so I want y'all to raise your hand if you think it was a chemical change that occurred. Okay, now someone tell me why. Let's see. Who wants to tell me why? All right, Colt, looks like you're the winner. What do you think?
Because you mix two chemicals together and it makes fizz and bubbles. And it's not physical because they're not physical.
So can you tell me what chemical property you saw, since you think it was a chemical change? Do you want to phone a friend? Does anyone want to help him?
It changed the odor because
Yeah. So there's probably a new odor smell. It probably smells different than when you smell both of them separately. They smell different when they're mixed together.
It didn't really change the color because the baking soda was white and the this is clear, so it was
Right. So does anyone else want to share why they think it was a chemical change? There's all kind of different right answers. I'm not looking for one specific one. I'm looking for, there's just anything that you can back up.
I think something's cool.
You think the same thing as Colt? Does anyone else agree with Colt?
Yeah.
Yes?
Raise your hand.
Okay, so raise your hand if you think it was a physical change.
Ooh,
You
you
do?
do so, man.
Question, are you gonna say both?
If you
I don't
think it's
know.
both,
If you can back it up, then it could be both.
Because we think it's both.
You might be correct. Share with the class why. Why do you
We
think?
think it's both because
Are y'all listening?
it had a chemical reaction with the baking soda, the soap, and the vinegar,
Mhm.
but the glitter didn't all come in one, so it was physical for the glitter.
Right, the glitter didn't change, so it's physical.
And also it's chemical because of the baking soda,
Yeah.
vinegar, and the soap because it had color change, size change, and shape change.
And what are those properties of?
Those are properties of physical change, and the
Uh-huh.
color change is part of the chemical.
Yeah. Okay, what about you, Amelie?
I agree with that.
You think it was both? Well, y'all did not get tricked because that was a trick question. There was physical changes and chemical changes that happened both during it. Does anyone want to share one that wasn't mentioned that you can think of? Is there one that y'all can think of that wasn't talked about? Okay, I have one. Oh, you have one? What's yours, McKenna?
Probably how all the base didn't rise completely to the top because it didn't go out the top, so there probably wasn't enough of vinegar or probably wasn't enough baking.
Yeah.
So, because it only went out the mouth and some of them went out the eyes, but not a lot.
Right, so if you do more vinegar and more baking soda, it'll be a bigger reaction. What do you think, Brody?
This is a question.
Okay.
I want to know what the soap helped it do.
The soap helped it bubble up.
It smelled
Because like the vinegar and the baking soda make it kind of rise, but the soap makes it bubbly.
That's why. That explains.
It did make it smell a little better too.
That explains why it was like. It's
Okay,
way
so
top.
I want y'all to tell me if this would be a chemical change or a physical change. When Gracie and I bought this pumpkin, it looked like this. But then we carved it, and we had star eyes and a mouth and a nose. What kind of change would that be? Would that be a physical change or a chemical change?
Physical change.
Exactly, the pumpkin did not change. Good job.
Probably because y'all changed it and only like the physical people.
Right, it's still a pumpkin, so like we cut pieces out and it didn't change into pumpkin pie. It's still a pumpkin, right?
Yeah.
Yeah. Okay.
Alright, so what we're gonna do next is just a little assessment to see what all we learned. So if you open your foldable up, there's a little chart, and there's gonna be examples of both chemical and physical properties. So what we want you to do is if you think it's a chemical reaction, just write the letter C in the column. But then if you think it's a physical reaction, write the letter P. And it's okay if you get it wrong. And you can also use your definitions and look back at the properties that you wrote on the front of the foldable to help you out.
You can write C and P if you think some of them are both, like our pumpkin. Are you looking? Okay. Thank you. Are y'all working on those? Use your definitions and your properties.
Thank you.
What would be your guess? That's okay. Did you do them all? Physical? That's a really good guess. You should also look at which they properties. See what some one that made the
You see, read it, and one of those occurred, then that would be a P. Kind of check yourself a little bit. You can go with that. That's a really good observation. What do you not get?
This whole thing.
What? Look, you can use these to help you figure it out. Look. This. Look, did you use the sharp? Here, a pencil was a new substance form, is it still a pencil? What would it be? Oh, that's the wrong one. There you go. Put it on the pencil. You put it on the rest of your card. Okay. Think like that. And look, you can use these to check yourself too.
Yeah, leaves won't come back when you burn them, will they? That's a good observation. Did y'all finish the exam? Did that help?
Okay.
Good job.
Oh, shoot. I think that's, there we go. Now it's okay.
As long as you tried really hard. I think you tried hard.
Oh, got one what? That's okay. Whatever you think.
Melting
You can kind of check yourself. I know, some of them are up on the board.
melting butter.
Uncle Fun.
About what?
Melting butter.
Melting butter?
And then lighting and
And then once we put it up,
Fireworks we talked about
brown
fireworks.
and turn
It
into
is on
People, look at your properties. You put whatever you think. You can use the little properties that you wrote to help you.
Y'all good?
Have you melted butter before? What happens? So you got a stick of butter. And what happens when you melt it? Is it still butter? So was something new formed?
No.
No good? So then what would it be?
I'm proud of you.
Sounds good to me. So when you're done with that, I want you to make a confident face or look confident. You can do this to look confident, or you can do whatever you think a confident face looks like.
Next, we have model face next.
Sure, we'll do a model face next. But right now, look confident.
Do y'all feel confident about chemical and physical reactions now?
No. When you're done, just make a confident face. You were doing good.
I think I got all of them.
Confident, Easton. Are you confident?
Half of them are
That's okay. Are you confident? Look confident. Well, make a confident face when you're done. There you go. Okay, I think everyone is ready. So,
Taylor, confident face.
what?
I said, I was told Taylor for confidence face.
Oh, that was nice. Okay, so once you have your foldable, I want you to hold it in the air. And Miss Gracie and I are going to come take them. Oh yeah, put your name on it. If you haven't put your name on it, put your name on it, sorry.
I got it mixed up.
Thank you. Thank you.
We need to put our last name in our.
You don't have to. There's your name.
I put my last name in just in case.
There you go. Thank
There's
you.
two rows.
Yeah, that could be confusing.
Not today.
Thank you.
Where you want me to? It's okay. I'll let y'all look at them and figure out what they are.
Okay, now everyone show me your model face. If you were modeling, what face would you make? Whatever you think it is. Brody wanted to do model face, so I want everyone to show me a model face. I like it. Okay, so I want you to talk with your group and decide on one thing that you learned, and then pick one person who's going to share it with the class. Pick one spokesperson, and then decide on one thing that you learned, but make it specific.
So think of one good thing you learned, okay?
Is it glitter Say something that you learned.
Don't forget to We're not. So,
Yeah.
what's something that you learned? Do you know the difference between your chemical and what's the difference?
like
You're saying
So go pick your person and then you share with the class.
Can't. That's a good observation. Don't forget about it when you can share it with us, okay?
Okay. Have y'all figured out your person and what you're gonna say that you learned?
got it.
Okay. And then go back to Okay. So we're gonna start with this front table, and y'all be quiet and listen to them. That way you can hear something that they learned. Because if someone says what you learned, what you were gonna say, you gotta change it. Think of something else. Okay. Okay. You want to stand up and tell us? You don't have to if you don't want to.
Can I say mine first so nobody takes it?
He's ready. He's ready. He's gonna do his.
A chemical change forms a new substance.
There you go. I like
Okay,
it.
I got a different one.
Okay. Your back table. What y'all learn?
Which part of it is what he said?
Huh?
Part of it is what he said.
Okay.
Chemical change forms a new substance, but physical change forms the same. Or doesn't form at all. It's the same.
There you go. I like it.
That was
No, I
good.
like it. You were right.
Who's laughing at me?
It's okay.
Maybe it's the glitter making them giggle. Okay. What about y'all's table? What's something that y'all learned?
I don't agree with them. I really do not understand.
You can sit there and say it. Just say it from your desk. Look, there's so many different answers. You're probably gonna say something that's correct. Believe in yourself. Be confident.
Well, you got this ready.
Just anything that you learned.
Okay, I learned if you put baking soda, soap, and vinegar mixed together, a lot of it makes like a big fizz.
Yeah, and was that a yes? That was good because we saw chemical and physical reactions. What about this table? Who's gonna share?
Y'all could have
Okay. Hey, listen. You gotta be quiet. Listen to them. Y'all
You're
just
good.
stay
Y'all can
right
share
there.
it.
Stand at your desk. Just y'all can share. Shh. Y'all listen. Y'all listen.
Today we learned that baking soda, soap, and vinegar makes a chemical reaction which acts like elephant toothpaste.
There you go.
Which, if you have not seen on YouTube or TikTok, is like a big explosion and it's very hot.
Oh, listen. Listen. Look, we have one table left. One table left. Listen.
Today we learned that if you put soap and salt and vinegar, the soap will make it.
Yeah, the soap does make a bubble. I like it. Okay. Does anyone have anything else they want to share? Amelie, what did you want to share?
I want to share I learned today. I asked Ms. Gracie if an allergic
Are you listening?
reaction was a physical reaction, and it is.
Yeah, that's awesome. I like the connections that you were making. So, another day, Miss Gracie and I are going to be teaching, and we're gonna help y'all do a STEM challenge. Does anyone know what that is?
Yeah.
Do y'all know what STEM stands for? Science, teaching, engineering, and math. And so we're gonna do a challenge to see if y'all can complete it based on our chemical and physical changes that we learned about. So you gotta make sure you remember. That way you can use what you learned to help you complete the STEM challenge. You don't have to, but you can if you want to. Actually, we took them up, so we'll bring them back.
Yeah, we'll
Yeah,
bring
we'll
it
bring
back.
it back.
When are you going to bring our scientists back?
Do you want it back?
Yes.
Okay.
No, ma'am.
Okay, well if you want it back, you can let us